So today we're gonna cover some changes to Monty, some recent changes to Monty and its two motor system. Um, but you thought this is a PowerPoint presentation. Gotcha. Okay. So this is actually just a series of diagrams here. We're not going to go into a great amount of detail, but basically just some of the new changes, enough to get a grasp of what you might need to know if you want to work with the motor system and the policies and write some new stuff. So, in short, the motor system used to be a class that contained a policy. That was it. So, whatever you wanted Monty to be able to do had to be encapsulated within that policy. So, that's meant that policy could jump to goals, do random walks, follow curvature, whatever it is. Any combination thereof had to be done by a single policy, which made it quite hard to sort of mix and match the different behaviors of a policy. In the simplest way, we've just basically added this layer called policy selector. In this example, is equivalent to what's on the left here. It might look a little trivial because there's nothing being added here really, no new behavior. But this is what that would look like if you wanted to just do it right now. And actually, the surface policies are still like this. They still basically contain the sort of multitude containing policies like surface curvature, informed, and so on. But this is what you can do with the new system. You configure your policy selector with any number of policies that you want to be able to use, and the policy selector handles the logic for deciding which of the policies it will select to enact whatever goal you may have or not have. So in reality, what it looks like is that we've got this policy called jump to goal, which was extracted out of informed policy. If we receive a goal from, the Monty, the thing that contains the motor system and passes all the information around, and that goal comes from a learning module, it's going to select this policy. If it receives goals coming from the salience SM, that's supposed to say SM. It'll use this policy, which simply just saccades to a location instead of sort of transporting and teleporting to it. And if there are no goals, it defaults to this sort of random walk. It's got a longer name than this, but I think it's called informed policy random walk or something right now, but that's just a sort of a legacy thing. So what information does the selector have in order to decide which of the policies, like if you write a policy selector, what information will be available to you? So this is what the selector protocol looks like, and this is all the information you'll receive at runtime for making the decisions. Observations, that's the full suite of raw observations that comes out of the simulator, post-transformation and everything. The state, that's the motor system state, so you get to know the proprioceptive state of Monty. This percept here is the CMP message that corresponds to the first sensor module. And the goals here, these are complete list of all the goals that were generated by learning modules, sensor modules, and so on. So this is all the information you'll have. And that's sufficient. I mean, that's basically all the information that Monty has, period, except I think technically it would have all the percepts from all the sensor modules, so it's pretty close to being everything that Monty is aware of at any given moment. So final point here, I said this is going to be short, but the final point here is that should you decide to go and make a new policy selector and a new policy, this is, for example, we talked about in the technical research meeting, a policy that would help us sort of dwell on the logo a little bit. So it might saccade to a new area, maybe spiral around it, do some sort of local things to stay on the logo, and then do another jump. So in that situation, you're talking about a policy that takes, let's say, 5 steps to complete. It's a multi-step sort of process. So that means you'll have to figure out how to persist it across the steps. That's just kind of up to you. There's no sort of unified mechanism um, for saying, uh, well, actually, I want to amend that statement. There is the policy result object that it returns by the policy does have a flag called status, and that status can say like in progress. So the policy can tell you whether or not it would like more steps, for example. But it's really up to the selector to decide whether or not it's going to do that. It's not enforced in any way. So what this means is you'll have to make decisions like if I'm in the middle of doing this 5-step thing, like Rami was talking about, and the rest of the team research meeting, then what do you do when a new goal shows up? Do I abandon the procedure I was doing in favor of the goal execution? Do I, and if I do ignore the goal, um, do I want to save it or do I just want to like let it pass by? If I do switch to executing this goal, like if I decided it's higher priority, do I need to reset the state of the policy that was doing the little spiral thing so that next time I use it, it will sort of start from its beginning state? Or do I actually want to resume from the state it was at after the goal? So these are all just sort of uh, up to you essentially. And this is what you'll write into the policy selector. So those are just sort of like caveats. Are there any questions thus far on this topic? Pretty
So
clear?
the motor system state, could you go a little bit into more details about what's included in that? Like, is it just the location of the agent or um, what kind of state?
Location and orientation of the agent. Location and orientation of all the sensor modules or sensors, I guess. That's
Okay,
it.
so that's
So it's all this, it's exactly the motor system state slash proprioceptive state that is being passed around Monty everywhere else.
is that something that's like ground truth that we get from the habitat simulator, or is it something that we just like accumulate movements on to calculate? Do you know if
It
like
is ground truth coming out of the simulator.
okay.
Yeah. Though it doesn't necessarily need to be. You know, if there's some implementation where that state information is computed in some way or whatever.
Hmm.
Um,
Okay, nice.
I mean, I don't know when that would be. I did think about that a fair bit yesterday when I was doing some 3D compositing in Blender and how we're able to sort of estimate our own locations because that's a big part of that process, 3D compositing. It's actually pretty neat how that stuff works. But yeah, so it could be estimated or computed, but as of now, it's coming out of Majoko or Habitat. Um, I couldn't
And
think of any other tricky things. Oh, sorry.
oh, sorry, yeah, just if you go back up to the code part again,
Yep.
the difference between observations and percept right now is that observations are kind of the raw observations from the environment
Yes.
and percept is processed by the sensor module.
Correct.
Okay, thanks.
I think uh, so. This raw observations, for example, um, that gets used. Who uses that? Jump to goal uses it to evaluate whether or not its jump was successful and potentially undo it. Though I think it could be switched to using percept. That's just a refactor we didn't do.
And
Um,
the reason why it's only the output from the first sensor module is that just because none of the policies currently look at any of the others, or
correct.
um, okay.
When we did this whole refactor, we just said, what is all the information that every policy is using? Some of them use that first percept. That's just the way Monty was made, with the curvature following, for example, uses whatever that sensor module is. It just assumes to be the first one. And we just kind of included everything that every policy uses. And this is everything. This isn't to say that this couldn't be changed, augmented, constrained in the future or whatever. This is just everything that current policies use and need to have.
And then, yeah, sorry if you said this, but in terms of the kind of code and or like the classes, I think you mentioned in a recent meeting that the motor policy selector is essentially a policy, or you could think of it as a meta policy, in that it returns
Mhm.
a motor policy result. but it looks like it's still implemented as a separate protocol. It's
Yes.
it's not like,
Yes.
yeah, so there's no inheritance or yeah, anything like that.
Right.
Or the
You're
same.
preempting my final
Oh, okay.
slide.
Okay.
But yeah, so it's a good segue, which is that right when we were wrapping up the edition of the selector, we noticed, hey, the literal only difference between a selector and a policy itself, in terms from a protocol perspective, is that a policy input to the call here is not a list goal, it's a single goal. And it's like, that's a pretty tiny difference. It'd be pretty easy to just say, hey, policies can take a list of goal. And maybe it's a one length list because like the policy that calls it had winnowed that list down to one. Maybe it, doesn't have any because the policy that contains it or called it eliminated all the goals, it filtered them out. So really all a policy has to do is has to be callable with the set of goals and has to return a motor system result. Kind of doesn't really matter how far you rush into all your policies. So that's yet to be refactored, but that is sort of the direction I think we're going. So yeah.
Yeah, that makes
That's
sense.
cool. So you could nest them deeper than 2 levels, basically.
Yeah. Yep. Do whatever you want.
You can make
Tristan
your
seems less
life as
enthusiastic.
difficult. You can make your life as difficult as you like. Yes.
Yes.
Thank you.
Um, yeah, nice. And then maybe I thought in terms of language, maybe just to mention to Jeff, I guess it's maybe fair to say that it's become clear that goals, as we refer to them here, are what we've more recently been calling targets, because it's always like a spatial pose. It's not about a state of a learning module. We kind of tried to clarify that language in London, that like you have a
Right.
kind of a goal state is what a learning module tries to achieve. Whereas the sort of more subcortical systems are more receiving these target poses that they then need to achieve. And so actually everything we currently do and pass is more of this target pose.
Is that, I mean, I'm fine, whatever, how you want to use the word, but would it be better to call it a motor goal or something like that? Or, I mean, how would you
Or
just,
I think we even said maybe at some point we can rename this one to, target pose or something like that.
right.
But I think it's just interesting because actually clarifying that language just made it more obvious that right now we don't have learning modules receiving goals from other learning modules, which also makes sense because we don't really have a concept of state and a way for them to yet implement it.
Right. Right. Okay. I think it's helpful, although honestly, I didn't understand what Scott was
Okay.
presenting because it's just
Okay.
it's been a long time since I've written code. So, and I don't know the internals of our system. So, I think as a general rule, it's interesting to think about language because, often in our research meetings, we'll say, okay, let's be very precise about the definition of this, and let's be very precise. At some point, we would probably need a list of all of our terms and exactly what we mean by them. It is very confusing at times.
Yeah, it's a fair point. I think we technically have a glossary in the README documentation, but I think it could do with
Oh,
updating.
maybe I should read that. Maybe I should print it out and post it
It's
on my
pretty old.
monitor.
Yeah, I think we have
Post it
to
on my
update
monitor.
it.
I'm thinking like, when
But
we write the next book or the next big policy paper or whatever it is, and we'll have to be, when we describe the entire system that we've created, we'll have to have that glossary. And
right. And it also makes me think of kind of like the move towards the 1.0 platform and breaking changes, because I feel like we have kind of breaking changes at a conceptual level as well.
yeah,
We might be like, it is a pose, a feature at a location in version,
Right.
Alpha, whatever,
right,
0.3. And then later it's like, no, it is a displacement with a feature. And the
right.
displacement is separate from the feature. And then someone's like, oh, wait, what? I have to update all my models to the new version.
Right. Interesting. Yeah, we have the same problem in theories that we have typically in code. So good point.
We should mark our theory with the
Oh, with version
exclamation
numbers.
mark for the breaking changes.
That's funny.
Oh, I'm gonna break some more in a minute.
Wait, undo commit, undo commit.
Oh boy.
But yeah, so this was a kind of a very, very high level summary of this huge effort that Scott and Tristan undertook over the past months of basically giving Monty's motor system a complete overhaul. And before it was quite messy and all over the place. And yeah, I would say now it's like much more structured, much easier to work with, much easier to extend, and it has this really nice new ability to be able to have multiple policies and switch between them during an episode or during Monty's kind of learning cycle and an experiment. And so, yeah, really nice project and changes.
Yeah, and
Thank
I
you.
guess as part of this, you also fixed the motor policies, the effect of the motor policies and how they were executed used to be deeply embedded in the environment data loader kind of way. Basically, we would kind of present new observations to Monty, and that was just a real mess and probably scared off some people who came and looked at Monty and wanted to work with it. But that's much cleaner now.
Yeah, hopefully, I mean, I think the changes we made over the past several months to help contain and isolate behavior of the system in a much cleaner way, much more obvious who does what. So it should be, much easier to develop. Like making your own policy now is pretty trivial, and you don't need to worry about a lot of things you used to have to worry about in terms of when do I get this information, who gives it to me, and so on. So yeah, hopefully this encourages anybody in the community that wants to, like if you got a robotic system you want to try out, or even just something in simulator you want to try out. Hopefully this makes it much easier and much cleaner to make that happen. I will mention a couple other points. What are the interesting conversations that we've been having throughout this whole process about goals, and like what does a goal mean? For the most part, goals in Monty are perceptual goals. Like that's how the motor system interprets them and policies interpret them. Perceptual goal as in, here's a location in space. I want to observe it with this particular sensor module zero. That's sort of the assumed meaning. Is almost true. That's almost true. The goals emitted by learning modules are actually goals for the agent's position, but I think we'll probably want to change that. That's a small refactor because the goal it emits is actually the location it wants to perceive, plus a little offset and how I want to be pointed at it. And so that's a slight difference there.
It's funny. It's
yeah.
funny you use the word perceptual goal. Again, wording is confusing because to me, a percept is it's sort of the inference result of some result of inference in the brain. It's what you think is out there, as opposed to a physical goal, like move the sensor to this location. So, I'm fine. We can use whatever word we want, but that's how I interpret percepts. Percepts are like it's not reality. It's what you perceive.
Right.
It's your inference. But
I
you're
guess that's all
using
we have, eh?
Yeah. Well, I mean, so again, I don't want we don't need to nitpick it here, but it is those. When you say perceptual goal, then you say, "Oh, it's to move the sensor to this location." I say, "Well, that's not a perceptual goal, at least not in my head."
I
But
think,
Right.
I mean, I think what you meant, Scott, if the learning module says, I want this to be my perceptual input at the next step.
Yes.
And so the input that goes into a learning module is already processed. So either it has already gone through a sensor module that did processing and extracting important information about it, or it might come from another learning module which did processing and inference on it. And so basically the idea being the learning module says, my goal is that my next percept, my next input looks like this. And yeah, like Scott said, it's not like that. Currently it says I want the agent position to be here, but it
would that
could
include
be
something like, okay, I want to find my phone, and that's the next thing I want to perceive, and I don't really know where it is yet. That would be like to me a perceptual goal. Like, okay, I'm looking for that thing. I don't think that's the way you're describing it. Maybe
I
it is.
think, yeah, that's the way it could be in the future. That
Okay.
you say,
Right.
okay, I want to see my phone.
Yeah.
And so someone else figure out how I can achieve that.
Right.
Yeah.
Okay.
Yeah, that's where I think the policies could get really interesting and more complicated. But figuring out how to factor one goal into several other goals, or what to do if one of them fails. Do I want to like kind of try some different options in the next? Um, but currently, we don't really have a. I think it's undecided yet how we want to identify what a goal is intended for and what it really means. Right now, it's just kind of data, and it's up to the policies to sort of interpret them. Um, I think is an interesting sort of ongoing conversation. How do you encode the target of this goal, or who's it really meant for? Is this meant for the agent's position? Like, is the agent supposed to perceive its own location, its own position at at the next time step to be this particular thing, or is it this location in space that I want my eyes to fall upon? So interesting kind of
Yeah, and I feel like
conversations.
that's where, yeah, kind of clarifying almost that goal versus target could be helpful because, like with the phone example, like it feels like the goal of observing a phone would be appropriate for an learning module to have.
Mhm.
Um, but that's not what we want to pass to the motor system because it shouldn't know what phones are. Um, and so kind of finding the right way to sort of encode that, like you say, kind of, yeah.
That's what I
Yeah,
thought. Like motor goal it would resonate with me. It's like, oh yeah, it's a motor. It's a low level non model based goal. I think what you're saying.
right. Yeah. Yep.
Maybe a
I think.
displacement one day
Yeah.
rather than a
Oh,
location.
gosh.
But yeah, right now
Uh,
it's a location and a pose.
So I guess I'll make one other final note, which is that the service policies have not undergone the same degree of chopping up that the distant policies have. Meaning the surface policy curvature informed still inherits from surface policy, which still inherits from the old informed policy. Um, it would be some work, a small amount of work, to give it the same treatment that the distant policy has. So make a surface policy selector that uses jump to goal and uses curvature following when there's no goal and that kind of thing. But that hasn't been done yet. So if you're looking at the code
Yeah,
base, then
right. Yeah, and I guess just in case anyone's, I don't know, watching this on YouTube and wants to start working on that or something, I'm guessing that, or like it feels like collapsing the standard surface and the curvature surface into one class could maybe be doable and just have it such that depending on the hyperparameters, it either follows curvature or not. And I think in general, simplifying the curvature one would be nice. Like it has some sort of like it a bit like the Saccade policy. It has a little bit of a memory, but it's
Mhm.
almost of where it's kind of visited in order to avoid kind of returning. But it feels like a lot of that it would be nice to move to learning modules in the longer term and make because it's veering on kind of model based to have this kind of notion of locations we visited and stuff like that.
Mhm.
Um, but yeah,
Yeah.
all I guess for one day in the
Yeah.
future.
The service policy code is quite complicated. It takes up a large portion of our code. So yeah, if anybody wants to take a crack at it, post on discourse and I'll follow it or open an issue or something. Um, but yeah, I think that's pretty much it. Tristan, do you want to add anything about?
The only other note I would make is the other exploration that we did, which I still think might be worth going into in the future, is when you look at these motor policy code, you see a lot of like if this, then that kind of if else branching sort of structure. So for example, let me share. So if we look at auto policies. So let's just take like jump to goal policy up here. Jump to goal. So here's a call, and you'll see it's has this if we're jumping, then if this, then if not, then if, etc. And then another one is we have the new informed predefined policy is not one. There's a new informed policy random walk, and it says if this, then do this, if this, then do that. And I think if you look at the old informed policy, which is still used, like Scott mentioned, you see this. If we're this, then do this. If that, if. Every time I see that, what this essentially means is we are building state machines, finite state machines. And depending on if you learn about state machines and you get like it's an equivalent way of expressing this logic, and it's easier in some ways and it's harder in some ways. And so one of the things explorations we also did is maybe all of our policies should be implemented as state machines as opposed to not. A state machine would look like that random walk state machine. Um, would look kind of like this. You define your states, and then you're saying, if I'm in my initial state and I'm on object, I'm going to sample an action. If I'm in my initial state and I'm off object, I'm not going to take an action. If I'm in ready state and I'm on object, I said, so you kind of get this sort of expression versus reading that if tree. The difference being is in state machines sort of show you here. This describes a graph, and Scott can actually generate nice pictures showing you how everything transitions to each other. Versus if you're looking at this code, you have to simulate it. You're essentially simulating state machine in your head to get it right. And so,
Yeah,
what?
and I guess there can be like if used for other reasons, and so you kind of have to like figure out is
Yeah.
the if kind of specifically the state or not.
Yeah, so right here you write down the imperative code of what's going to happen, and the state machine needs to be formulated inside your head correctly, or you can just spell out the state machine. The reason I'm saying they're kind of similar level of effort is because it takes a skill. You have to simulate the state machine in your head to write it down. It's not magic, but sometimes it is easier to reason it out, your policy out from a state machine perspective, and sometimes it's easier to do it from this perspective. They're again equivalent representations. So we have some examples of state machine implementations, but we decided this was way too much for this effort, etc. But I just want to kind of give that side note for us or anybody else implementing it is like these policies are pretty much state machines. So any state machine approaches, finite state machines. So any state machine approaches are likely to be viable and very successful in these policies. That's it.
Yeah, no, I think that makes sense. And I guess in terms of understanding, I guess with the state machines as well, someone coming across that, like I personally haven't come across state machine implementations in Python, like the kind of syntax for that. So I guess it just requires someone to become familiar with that, but it doesn't look super complicated. So as long as we kind of direct people appropriately to that, and I don't know, not assume that everyone's come across that, that'll probably be fine.
Can I ask a clarification on that very issue? So I don't really know Python, but I was wondering, is that a built-in thing into Python state machines, or did you create it and write code that sort of looks like a state machine? I was
we
actually,
just we pulled in a library that implements state machines. Pretty much every language has a state machine library that's sort of
got
the
it.
canonical implementation of
Right.
state machines in that language.
Uh-huh.
And so we just picked one of the widely supported ones and just expressed everything in that. But it usually does. It's weird because state machine libraries usually do weird things to the language because it seems like every programming language is kind of it's hard to express state machines like very concisely in them, except I guess, specialized languages. But every language has a library, and this is what we used here. We like use one of the main
Mhm.
state machine libraries in Python.
It's certainly a lot easier to read. And I guess
Yeah.
that you're saying it's like you don't have to build that model in your head, right? So interesting. I just didn't, when I programmed, they didn't have anything like that in any language. So I didn't know if that's common now, but as a library, not as a built-in function.
Right.
Well, these policies, there are a lot of if statements and states, like Tristan was saying, and I'm just wondering, the more and more complex they become, do we imagine the future that we'd have learnable policies, or is the learning only happening in the LMs? And we do.
Yeah.
So,
Yeah, we definitely want learning.
Tristan, you want to mention the reinforcement learning? Like, there's a good,
I mean,
no,
I was just gonna say towards reinforcement learning. Like
yeah,
we've given it thought. Scott, you were exploring, right? Like you asked the question. Oh, right. There's like the FSM. Okay, so if you Google in final state machine reinforcement learning, there's actually a GitHub repository that implements reinforcement learning on top of finite state machines. So that is one way we could do RAB reinforcement learning all over this. But
So
yeah,
basically, we define, sorry, so we define the states, and then the reinforcement learning selects which state
right.
to go to. Okay.
Something like that. It's somebody's recent thesis and open source code, so I have not had a chance to look at it. It just there's a direction. But the other things Kat and I were wondering about was also, I mean, you have your inputs and you have outputs that's readily defined. You could just wrap it in a reinforce, you could just wrap it in a network, right? Like
Yeah, and that's
have
actually where we have a community RFC on that open right now. Basically, you get a goal, the target pose from the learning module, and you know the pose of the agent at the moment, and then use reinforcement learning to figure out how to move from current pose to target pose. You can use some additional perception, like how far away are you from the object right now, and stuff like that to kind of adjust your path to not run into the object. But yeah, I think it's definitely something you can supervise really well, and that should be totally doable to learn with reinforcement learning for like various robotic embodiments. And yeah, could be kind of the subcortical part of Monty learning about how to move.
Yeah, this makes sense because I think that the complexity is just going to add a lot more rules to these if statements and a lot more if branches, and it's just not going to be sustainable.
Like
just
maybe the third example to bring up is like in robotics, they have inverse kinematics. It's like, a whole branch of how to figure out movements to enact a target pose basically. And so that's what like some people who are experimenting now with Monty simulation with like a robotic arm are playing around with, and that seems to be working pretty well. Um, and the cool thing about I guess the modular nature of this and how we can nest these policies or kind of combine them is, yeah, you can imagine a mixture of these things as well. Um,
So the policies right now is just about moving from one location to another, but it's not about the like thinking about is there any higher level thought that goes into the decisions that we do in the policies, or is just going to be as basic as, I want to move from one place to another and just figure out the trajectory.
pretty basic. Yeah.
So the thinking is going to
Well,
happen.
so yeah, what a policy returns are actions that get, handled by a simulator or whatever. So you can kind of just think of a goal as a location to go to or to look at. That's really it. And policies handle, move forward or whatever. They emit move forward, look left, and that gets, absorbed
I
by the
guess
simulator.
encapsulating the problem you were talking about, which is the encoding of, I want to encoding of the perceptual goal to the motor goal. And I was thinking that this could happen in the policy or it could happen in the learning module, and I wasn't sure. I guess it would add a lot to the complexity if we do it in the policies. Um, but it's also there's a lot of learning that's going to be involved if we do it in the learning modules. So
Yeah, I think generally for more complex, kind of like orchestrating a series of things and stuff like that, we'll want to tap into the learning modules. And that could include, eventually a hierarchy of learning modules that model the embodiment. Um,
Yeah. In that case, then the policies are just going to be pretty basic, like you guys said. And the learning of this encoding could happen in the learning modules.
Yes, it's interesting to think about how to reframe these kinds of things. How do you
Yeah.
create these goals, factor them goals in the language of learning modules and what they know and what they do? Yeah, and maybe like Tristan said, keep the motor system pretty simple. Try to think of it as a subcortical thing, and you can do all your special little logic there. Maybe embodiment specific kinds of things, probably embodiment specific kinds of things, and then yeah, we do our higher level work in the rest of Monty and learning at the learning module level.
Kind of the reason behind that pitch is like just keep motor systems simple. I can imagine alternatives, right? I can imagine a cerebellum simulation inside the motor system, right? That's like, and then all I'm saying is let us not be the people who do that. But the other part of it is I also and again this is coming from the just code organization perspective, etc. Is it's my understanding that you're gonna need a lot of learning modules in order to build a motor cortex out of learning modules. And so we're not there yet, so we can probably defer complicating the motor system until we have learning modules reverse engineered and start assembling them into something that then will take over or at least make a digital twin of the embodiment inside, whatever the motor learning module motor cortex is. But I feel we might get there faster if we don't spend our time in doing 3D transformations in the motor system. Um, it's I do not
Yeah.
like those.
Yeah, I'm with you. Although it's interesting, I think I've mentioned this before. I agree. We don't want to do the cerebellum, but the cerebellum is actually far, far simpler than the cortex. So people have figured out its algorithms a long time ago. And but I agree, we don't want to do that. It's like, oh, that would have been an easy task because it's already done in the 1980s.